Oh, good afternoon. Okay, good afternoon. It's 2 o'clock. And I have a couple of students in class and a couple of students online. So good afternoon for everybody. And I want to get started with these announcements, just to give you an idea of where we are and where we are heading. Semester is getting close to an end. So we have the next lectures after this one. So on Wednesday, we're gonna complete lecture 7, part 2. And then on Monday, April 25th, we have our second simulation exam. That will be in class. So you had to be here on Monday, April 25th. We have an in-class exam. Same way we did the first one. You are going to get an exercise and you'll be solving that in class. You have 1 hour and 20 minutes to complete the assignment. And then on April 27th, since you also have the project coming after the exam, I decided not to lecture on the 27th, just to give you that time for you to work on the project. So if you have questions about the project, we can meet, discuss those on the 27th, but there will be no formal lecture on April 27th. There will be no class. So you'll be working on your project, which is due on May the 2nd. So project final presentations are gonna happen on May the 2nd, that's a Monday. So Monday you have to come to class to give the final presentations. There is, I made some updates in the assignment, not assignment, but the project submission link. If you go there, you'll find 3 new files there. 2 of them are examples of projects from previous years. And then another file, which is giving you a format or a template for the final presentation. So for the final project or for the project report, you have to submit your report, and also you have to give a final presentation on Monday, May the 2nd. The second theory exam is going to happen on the day assigned by the register, May 9. The second theory exam, that's what's going to be on May 9. So that'll be after the semester is over. During the final period, our exam is on May the 9th. I don't remember the time exactly, but it's listed in the syllabus. So that's the plan for the rest of the semester. Do you have questions? Is the syllabus what? Oh, for the theory exam too? It's for the second part of the semester.
Okay. And we have another submission for lab homework.
Yes.
Yeah. So do we wanna have the solution before the?
Yes. So yes, that's a good question. So there's a final lab that is going to be due on Monday, which is the day of the exam. So I'm going to be posting the solution of that by the end of the week, let's say Friday, to give you the opportunity for you to work on that. But yes, you will get the solution. That's a good question. Actually, I can tell you right now that the topics that we're gonna cover today in the lab are not gonna be part of the exam. It's gonna be too much for you to learn those in a week, okay? So I need to cover those. You'll see in a minute. But I don't want you to worry about those concepts in terms of the exam, okay? Because it's going to be so difficult to remember. And yeah, but you need to understand those concepts because those are required skills if you are going to be modeling transportation entities in your system. Okay, so let me repeat that. Lab 2, I'm sorry, simulation exam number 2 will cover labs from 6 to 9. Okay, 6, 7, 8, 9. Lab 10 is not going to be part of the skills that are going to be evaluated in the exam. But you have to be aware of the skills that you need for 6, 7, 8, and 9. Does that make sense? Okay, so today we're going to talk about a new set of, a new module actually, new set of blocks that you are going to be using that we haven't used before. So that's why I think not to make it too complicated. That's not the idea, but these are blocks that you might need in order to represent systems in which you have, for example, forklifts moving around the system. Or transportation objects moving around the system. So, any questions? Okay, so let's talk about the skills or the new topics. Okay, so lab 10, this is the last one, modeling, analysis, and manufacturing systems. And these are the basics of simulation, so you understand those. Let's go straight to the blocks that we are going to be using today. And this is the modules that we are going to be learning today, the advanced transfer. So these are the type of entity transfers that can be modeled in Arena. The connect basically is the one that we've been using for the entire semester that requires 0 delay. So you're connecting blocks from using this connection. But you have other ways of representing movement in the system. For example, we have a block that is called route. Also can be used as a 0 delay transfer, but you can also add some delay within the block to represent a time that is needed for you to move those objects. Stations, animated routes, and you can have fixed routes versus entity dependent sequences. Connect and route both assume there's no limit on the number in transit at a time, and that entities will have their own feet. So you don't need another equipment to transport them. But there are some new types of entity transfers. These are resource constraint transfers and have limit total number of entities in transit at a time. So for example, if you have a forklift, you know that you can only move these many items in the work forklifts at a time. It's not like you will move unlimited or infinite number of entities. So that's why we call them resource constraint transfers. In telecommunications, that will be the number of packets, logistic number of vehicles, and so on. In material handling, some of the devices that we can represent using these new entity transfer techniques are the transporters, such as forklifts, trucks, cars, wheelchairs. Usually place limits on the number, capabilities of transporters, and this is like a resource, except it is something that can be moved. Conveyors also can be represented using Arena. We have belts, escalators, usually limit space on the conveyor. You have a speed also, and you have non-accumulating versus accumulating conveyors. So in this lab, we're going to focus on the transporter concepts and basically modeling cars, forklifts, trucks, wheelchairs, people. When entity is ready to go somewhere, it needs to be picked up and moved by these entity or these resource. We'll call it resource because it's actually a resource. You're going to seize it, you're going to use it, and then you're going to release the resource. So these use transporters are movable resources, and there's activities associated with them. So we need to request the transporter. We're going to transport the entity, and then we're going to free the transporter once it is complete. The process is complete. It's just like a resource in which you seize, delay, and release. In here you have request, transport, and free. Is the same idea. So the transporter selection rule, if more than one transporter is available when requesting, and when free and one greater than one entity is waiting, priority is closest to one. So we have to make sure that when we have an entity requesting a transporter, it's not going to move until one of them becomes available. There's two types of transporters. They're free path. Those are the ones that we're going to be discussing today, where the travel time depends only on velocity, distance, and ignore traffic jams and the resulting delays. But we can also model guided, such as AGVs, intersections, and so on, and these will be impacted by these resulting traffic jams if that's the case. But our focus today is just to introduce you to these new modules. And once you learn how to use the basic, I mean, you learn the basic stuff with this lecture, then you can easily expand on it by using the help and also the guidelines provided by Arena. So these are the blocks that we're going to learn today. The station block, the station module defines a station corresponding to a physical or logical location where processing occurs. So this is like representing an area in a company. Like you have the storage area, you get represented by a station. If you have the processing area, you can have a separate station for that. And then you can create your network of locations using these stations. Then you can also specify distance between stations. So when you request a transporter, if you set up a speed for the transporter, it's going to compute how long is it going to take for you to move that distance based on the speed. But this block is just to define the area. So station A, for example, in this module, if you double click, you will have a name, and then the associated state name. Station name is going to show up. And then there's a additional input here required. If you are defining a guided network, you're going to have to use this parent activity area and associated intersection. But for free transporters, you don't need to specify that. Yes.
What is the difference between process module and station
Process module and station
module?
module. The process is to define a resource, right? Station is just defining an area. It's not a place that you're gonna seize. It's just a location in the space. Okay, so you say, okay, station A is located right there, and is located, I don't know, this distance from station B. So what you want to do is to identify that area. There could be some processes happening in that area, but as soon as you complete the process and you need to move that entity from that area to another area, you will send that entity to another station using. Yes, yes. So this is basically is like saying this is the node where everything is happening. Once this process is completed, you're going to transfer from this node to another node. Okay, so that's the station. And then we have the route block. This route module transfers an entity to a specified station or the next station in the station visitation sequence defined for the entity. A delay time to transfer to the next station may be defined. When an entity enters a route block module, its station attribute entity station is to set to the destination station. The entity is then sent to the destination station using the route time specified. So the route, again, once you have completed all the processes that are needed in that area, you will send the entity to this route block, and the route is going to call or is going to send the entity to the next area based on the sequence of stations that that part needs to follow, or based on the specific station that you can specify here inside the module. So the module will have a destination type. That destination type can be a specific station, or we can define a sequence for the part, and this will call that sequence based on where the part is located. It will find the next station to send the part. And then the request module, this is for transporters. So the route block is used without, it's not trying to represent a transporter. The route block is like saying the part will transfer using any device. It's just gonna, you're not constraining the part to a specific capacity of a transporter. This is for unlimited type of transfers. In reality, this will be like, I don't know, like representing a conveyor that is moving parts from part A to part B. So when it gets to that part, when it gets to this module, it's going to be basically moving to the station based on the time that you are specifying into the system. If you want to have a constrained type of transporter, we will call the transporter using this request module. So for example, if you want to define a set of forklifts, let's say 2 forklifts in your facility, this module right here is going to be able to call that group of forklifts to do the transfer. So these assign a transporter unit to an entity and move the unit to the entity's location. A specific transporter unit may be specified, or the selection may occur based on a rule. When the entity arrives to the request module, it is allocated a transporter where one is available. The entity remains at the request module until the transporter unit has reached the entity location. The entity then moves out the request module. So as you can see here, this request is going to be calling a specific transporter. So we're going to define the set of transporter as part of the model. We're going to call that set, and then the selection is going to be based on these rules that we have discussed also for requesting a resource. So cyclical means that you're going to be rotating. And velocity can be also specified. And then we're going to have a queue for the request. So if no forklift is available, then the entity is going to be waiting in this block until the transporter becomes available. So here's are the transporters with selection rules. ESR. So cyclical, experiment rule, largest distance to station, prefer order rule, random priority, smallest distance to station, or the user rule. And so you see, depending on the situation that you want to replicate, you will select the rule that works better for you. So So the transport module transfers the controlling entity to the destination station. Free path transporter are always moved to the same station destination as the entity. The time delay to move the entity and transporter from one station to the next is based on the velocity of the transporter, the distance between the stations specified by the distance module. So say no for now. And when an entity enters the transport module, the station attribute and the station is set to the entity destination station. The entity is then transported to the destination station. So this is the transport. So you have the request, and now you have the transport, the entity destination type, and then you will specify where you want to go here, and then click OK. And as we do for the resource, we cease delay and then we release the resource. Same thing is going to happen for the transporter. So you call the transporter, you transport, and then you free the transporter. So the free module releases the entity most recently allocated to the transporter unit. If another entity is waiting in a queue to request or allocate the transporter will be given to that entity. If there are no waiting entities at the time of the transporter unit is freed, the transporter will wait idle at the free entity station location unless otherwise specified by the transporter module. So let's say you have, you're transporting this entity from station 1 to station 2. So transporter is free at station 2, so it will remain there until another entity calls, right? That will be the most efficient way of keeping the transporter, because if you move it to another station, unless you're specifying a station for storage of the transporters, you will be making additional movement, unnecessary additional movement, if you don't know where the transporter is going to go next. And then the distance module defines the distance between two stations in distance set of a free path transporter device. The beginning station, ending station, and distance are used to create the appropriate distance set, which is used in the simulation run by the transporter moving between these stations. So we're going to specify, according to a network, the beginning and the station and distance between those. So if there's a link between, let's say, so for example, if you have station 1, and this distance is 50, then you will have station 1, station 2, and the distance, I'm sorry, 50. And you will specify this network in this way in Arena for Arena to build the network and understand where you can go in order to move entities in the system. So if you have something like this, you will have to specify this distance, this distance, this distance, and this distance into this array, according to the name of the stations and so on. The sequence module is used to define a sequence for entity flow through the model. So this is like each entity will know I have to go to station 1, then station 3, then station 4, for example. You can specify that sequence and you can have a sequence for each part. So the parts will travel to the respective stations according to that sequence. So the sequence module it's used to define the sequence for entity flow through the model. The sequence consists of an ordered list of stations that an entity will visit. And for each station in the visitation sequence, attributes and variable may be assigned into the sequence model. So for example, here we have two sequences defined, one for part one and part two, one for part one and one for part two. If you click on the steps, let's say for part one, these are the stations that this part will visit. So it will start with C2, they will go to C1, and then they will exit the system. This exit system will be another station. But if you click on the assignments, let's say for station C2, when the part goes there, you can change the process, or you can assign a processing time attribute for that station, for that entity. So in that way, if you have different processing times for each part in the same station, you can specify that in the arrays. So a lot of information, 3 levels of information here. You have the sequence, and then in the sequence, you can specify what will be the processing time in that station. And the transporter module allows the definition of a pre-packed or guided transporting device for entity movement from one location to another. So in this module, you're defining, for example, this is the name that you're giving the transporter. You can specify the number of units, the type, and the distance set that you're going to use. So this is basically this, right? So you're defining forklift distance. So you're going to let the transporter know you're going to be using that distance set. Velocity per minute, initial position status. You can specify that too. Okay. So I think that covers everything we need for today. Let me go to the example. A lot of information here. So all we have learned. Oh, one thing that we need to cover today. I wanted to cover this before we end the semester. So you see, all semester long, I've been asking you to create this output report to report the statistics. But today, I want you to pay attention to not the average by itself, but also the half width. Why is this important? Well, we covered the we covered the quality control limits. This is not titled out this, but it's the same idea. We want to have some room for variability. We know these are random experiments. So by just reporting the average, we're not getting all the information that we need to make decisions. Okay, so typically, or what you are recommended to do when you're running a simulation experiment is not just reporting the average, but you also want to report the variability of these average. So Arena reports the average and the half width, and we can use that to compute the confidence interval for our performance measure. You will only get the half width for the output report, right? Because the output report is building a report based on all replications. So this is computing the average for all replications and also computing the half width based on the numbers that you got from all replications. So why is this important? Let's say, like for your project, you're comparing your current status versus a new configuration for your system, right? And you're looking at the cycle time. Okay, so let's say, for example, here we have a cycle time 62.116. And then I do a new layout for my project. And it looks like my TAVG now, cycle time, is equal to, let's say, 59.5. And this is the average. So original, so the original average for the cycle time was this, and the new average is this. What can you say about the system? Is the new configuration better than the previous one based on the cycle time? Cycle time is less. So you will say, okay, you're processing parts more faster. They're taking less time to be completed, right? So if you just look at the average, based on the average, you can say, okay, this cycle time is reduced, so I would think this system is better. However, by just looking at the average, you cannot state that. You cannot say one system is better than the other by just looking at the average. Why is that? When you look at these two systems, let's say this is system 1 and system 2. This one, let's say this is 55, and this one is 55, and this is 60, 60, 55, 65. So system 1, this one is 62. So 62.116, and this one is 59.5. Okay, so you can see in the plot that 59 is smaller than 62. That makes sense. However, when you take into account the half width, this is saying that there's a variability of 7 units. So that means that this will go about that space, that variability will cover. Right. So what the confidence interval is representing is telling you that your true average, the average of the population, can be anywhere within those bounds. Okay, anywhere based on this confidence interval. Same thing here. Maybe let's say that variability is the same. So you have, so those two confidence intervals are overlapping. Okay, so if two confidence intervals overlap, you cannot say that one system is better than the other. Statistically impossible, because you don't know. You don't know what the average, the true average for your system is. For example, this population average could be here, and this one can be here. And that could be possible. If the true average, the average of the population is here, and this one is here, what does that mean? Yes, system 1 is better than system 2, exactly. And if you just make a conclusion based on that number, 59, your conclusion is incorrect. Okay? So what do we do in order to make sure that we compare two systems and we make sure that we are selecting or recommending or bringing the right result to make a decision? The what? Yes, correct. So we have to reduce the variability of these confidence intervals. That's correct. For you to be able to reduce the variability, you have to run more experiments. So if you just run 10, your results are going to be based on those 10 scenarios. If you run 100, your variability will start reducing. If you run 1,000, your variability, so those intervals will become smaller and smaller and smaller because you're as you study more scenarios and more scenarios and more scenarios, you will have a better idea of how the population mean will look like. So those confidence intervals are going to start reducing. Okay. So at the end, you need to run as many replications if you want to get a correct recommendation. What you're shooting for is for something like this. You end up with 59.5 and 62.11, and then you have a confidence interval that is so small that there's no overlapping. See? This confidence interval and this confidence interval are no longer overlapping, right? So you're 100% sure that your true population mean is not going to happen, it's not going to overlap, or it's not going to be like in this case at the bottom. Could be anywhere. It could go on top of the other confidence interval, get the wrong conclusion, right? So the reason I'm bringing this discussion is because if you don't know these details and you come up with a better system, but you show your results and someone can easily tell you, you know, those confidence intervals are overlapping, you cannot make that conclusion, right? You have to make sure that if you're going to bring a recommendation, your numbers are showing that there's a difference, a clear difference between the two systems, and you are making the recommendation based on that. Questions? So for this lab, I'm asking you to report the confidence interval or the half width. For your project, I'm going to be looking for this. Like when you compare your system, that you pay attention to this. You can maybe for a couple of, maybe you have multiple performance metrics. So if you don't have to get, like if you're going to be making the recommendation based on cycle time, you need to make sure that these confidence intervals are not overlapping. Yes. If you see that those confidence intervals are overlapping, then you have to increase the number of replications that you're running. Okay. Okay, so we're good to go. Let's look at the example for today. So here's what we have. We have this network. We have a station that is called in, and there's 0 feet between in and station 1, 0 feet between station in and station 2. There's 15 feet between 1 and 2, 20 between 2 and out, and 20 between 1 and out. We have part one sequence goes to in, then to station one, is processed for 5 minutes, and then goes to out. The time between part arrivals is expo 5 minutes, and we want to collect the average number of parts completed for 10 replications of 10 days, and we're going to use a warm-up period of 1 day. Okay, so simple. Let's work on this. Stand up for a minute. Let's open Arena. And let me save this. Okay, so I'm gonna go here and I'm gonna find in the old Arena templates, the advanced transfer. Actually, I'm gonna add them all. Attached, advanced process, and basic process. Okay, so this is the new one, the advanced transfer. And here's where we're gonna start defining some of the network conditions. So let's see. Should we start by building the model first and then defining the rest of the data? Let's do that. Okay, so we're gonna start bringing the network. So we're gonna start with a create block. Why is it so small? New. So we have a create block. And this is gonna have entities arriving according to an exponential distribution with mean 5 minutes. If I remember correctly, yes. And then we are going to assign this entity. Since we only have one sequence, we need to assign that sequence to our entity. So the assign block that is going to be defined next is to specify the sequence that the entity is going to use. So let's bring that assign block. So this is a type other. The name is NS, number sequence, and the value is going to be 1. Okay, so for the sequence, we are going to define the sequence that these parts are going to follow. In this exercise, we only have one sequence. So NS is a number sequence. In this case, it's going to be just 1. So the value is going to be 1. From here, we are going to route, because we want to send this to the next station. We can actually link this to the first station, but I want to keep the station separate. So I'm going to use a route block. So go to advanced transfer, bring that route block. Double click. We're going to send this to a station, and we're going to call this station in, just like this one. I'm going to create the entities, and they're going to automatically be sent to station in. And click OK. So let me from here. We are going to create this station in. So I'm going to pull this station in here, the station block. And this is going to be my station in. So I'm going to change the name. And the name will be the same. I'm changing the name. The station name is what's really important. I'm changing the name just to give you an idea where the stations are. If I don't put in the name, it's gonna stay station 1. Changing the name is gonna change the station name also. And then from here, we're gonna have to start doing some work. We're gonna need a request, because here's where we're gonna start requesting the transporters to move our entities. And then we also need to oops. So we request and then we transport. We connect those. Okay, so for the request, I need to define my set of transporters. So let's find that. So if I go to transporters, I'm going to define my set here. Let me make sure that I use the same name. Transporters, forklift. Forklift. We're gonna have two transporters or two forklifts. They're gonna be free pad. Distance set. Let's keep it forklift distance. Velocity, let's say 40 per minute. Excuse me? Yes. Okay, so in the request, once you have coded the forklifts or the transporters, we can go to the request and set up the transporters that we're going to use. So if you go to request, you can select the forklifts. We're going to keep this cyclical. The rest will be the same. Okay, and then for the transport, we call the forklifts, and the destination is going to be based on sequence. And we're going to define that sequence in a minute. But that sequence is what we stated here in the part sequence. We go to in, then to station one, and then to out. So just click OK. Then we have similar logic to represent here for station 1, 2, and out. So we're gonna basically replicate. So let me save this. The next two lines are gonna be identical. We have a station. We need a free. So once the transporter brings this to station 2, we are going to free the transporter. Then in station 1, doesn't matter what this says, this is station 1. Okay, so we're gonna fix that in a minute. Let's do that now. I don't want you to get confused. So this is station 1. Should I use, yeah, let me use station 1. So when I click OK, this is gonna change from station 2 to station 1. Yeah, let's keep the, let's be consistent. So let's just keep the same name, station 1. Then we click OK. Then we're gonna free the forklift. Click OK. We're gonna have a process. See delay release here. Call it machine 1. And how long does it take? 5 minutes, right? But in this case, I know I haven't defined that yet, but we're gonna define it. This is gonna be a minute processing time. So we're gonna use an attribute. We're gonna define it in a minute, okay? Don't get confused. But we're gonna call that attribute when the part arrives. Click OK, and then we are going to do another request because now we are done in station 1. So we need to call the forklifts so they can move. Okay, so request forklifts, parts done. Let's transport it to the next station. So request and then transport. And we're going to transport using the forklifts. And the destination is going to be by sequence. Remember, we haven't defined the sequence yet, but this is going to be based on the sequence. We good? So for station 2, we're going to repeat the process. Actually, let's see if I can just copy and paste. I don't think that's not, let's not do that because I think that's going to create some troubles. So we have this logic. Let's bring another station here. Another free. Another process. another request. And another transport. And let's edit this. So station 3 is actually station 2. We are going to free the transporter name is forklift. If you don't do this, your system is going to get stuck. So you need to make sure that once you're done transporting, you go and free the transporter. If not, at some point, your system is just going to stop. You're going to get an error because entities are getting stuck and you're going to reach that limit. So if you get that error, make sure that you are freeing the transporters. And then the process, we have see delay release. Let's call it machine 2. The same thing here, expression, processing time. In minutes, correct. Okay. And then the request, transporter name, forklifts. That's all you need to do. And then transporter name, forklifts. And this is gonna be based on sequence. Almost there. Okay. The transport. So the last one is this station out. There's no processing happening in this station. So we are going to create a station here. And what we're going to do is that we're going to free the transporter. And then we're going to collect some statistics. And then dispose. So station 4 is actually out. Station name is also out. So that last station, the name is out. Station out. And then we're gonna free the transporter forklifts. And we're gonna collect some statistics. I think what we wanted, average number of parts completed. So we're gonna count, correct. Parts completed. No, it doesn't have to be connected. Route, you don't have to connect the route. Actually, if you see there's no connector in that block. That's what it's gonna do is just send it to the station that you want. Okay. Okay, so from here, we had to define other things. If you do check model, you're gonna get an error for sure, because there's certain things that we have to define that we haven't defined yet. For example, let's go to station data. So if you go to station data, we have 4 stations: in, station 1, station 2, and out. Make sure that you have those. And then you go to sequence. We are going to define a sequence. I'm going to call it part 1. And here's where we're going to state the stations that this part is going to follow. So in this case, we'll go to in, station 1, and then out. So we'll go first to station 1, and then after that, it will go to out. And we do have to do some assignments here. We are gonna call these attribute processing time that we define. Say that again. Yes, station 1 assignment, we're gonna call processing time. And the value is gonna be 5. So we have these 2 layers, right? So we're specifying the sequence for part 1. So since you're gonna call the transporter from station in, you don't have to include in into the sequence because you're calling the transporter from station in. You're already there. So from in, you're gonna go to station 1, and then from there you go to out. In station 1, you have a process. So you're calling the processing time attribute, and the processing time for that machine is gonna be 5 minutes. Okay, so let me close this. So we have this sequence. And we also need to define the distance. So we have the forklift distance. So this is what requires a little work. So from station 1 to station 2, there's a distance of 15, right? 1 to 2, 15. Then we have from station 1 to out, I think it's 20. We have from station station 2 to out is also 20. So from in to station 1 is 0. From in to station 2 is also 0. Let's see if this works. We have to define the statistics. The output. I think it was parts completed. Average parts completed. And see parts completed. Let me check my model. So let's set up the instruments. We're gonna run this for 10 days. One day, warm-up period, 10 days. The run length and base time unit minutes. Project parameters. Okay. So let's see if this works. Check model. Okay. Okay, so yeah, I was expecting this error. When you define the distances, you have to make sure that all possible combinations are covered. And we didn't define a distance between in and out. And we have to place a dummy distance. Like in this case, I will define that as 0. So let me go here to distance. forklift distance. So from see if that works. Yes. Okay, so try do the batch run. Yes. Another error. Too many entities. Okay, so we're generating too many entities. So let's increase the expo. I don't think that's the problem, but let's see. Yeah. So on average, we have 1,325 parts. 1,000. Did you do the warm-up period for one day? One day warm-up. Got it. Okay, so that's a good exercise. Again, these type of applications will come up a lot, especially if you're modeling a complete process, not just a manufacturing line, but if you're modeling a interaction between the manufacturing line, a warehouse, and multiple departments, then you will need to model also the material handling, and this is what the modules that you can use for those purposes. Any questions? So I'm going to stop sharing. Again, I'm going to be posting the solution for this by Friday. If you don't see it, you feel free to send me an email. But again, this is not going to be part of the skills that you need to know for the exam on Monday. Any questions?
Dr. Jimenez,
Dr. Perez, yes.
or sorry, Perez, could you possibly post this class model on Canvas just so we can, because I was getting an error, but I'm sure I can figure it out if I could just see where yours. Thank you.
I can do that. Anything else? Okay, good. So I'll see you guys on Wednesday.